I'll just start recording a session for the benefit of those people who are not able to join us. So, oops, not that. There's the wrong one. What am I looking at? Combined science. Combined science. Is this the right one? Great. Okay, we'll just get started with this work one correction first. There were 3 pieces of work for these rate of reactions. I can guarantee you rate of reaction will definitely come up for your O-level because you guys have a new paper called Alternative to Practical. There is your paper 3. Rate of reactions happen to be the most common practical that you can do. So far, you've seen all the questions. They are to do with practical techniques. And that is why I have high confidence that this will be something that will be useful to you. Well, hopefully next year, okay? But there will be a topical test on this topic, as well as the previous year 10 topics when you get back to school in about 2 weeks. So let's just make the best of it and make sure you can do the question that you're supposed to be able to do. For this work 1, work 2, work 3, I already provided you the tutorials. You might have gone through it. So I just very quickly go through it. Whatever that you miss, you can text me, and you can also go back to the PDF I just sent you to the group chat. Okay, anytime you feel like you want to leave, just leave, it's fine. Session is recorded. Just make sure you take down your attendance on the WhatsApp group. Okay, so here you have a metal and an acid. You get metal, salt, and hydrogen gas. This is from your year 9 chemical equation topic. 3 common acid, hydrochloric acid, HCl, H2SO4, HNO3. They give you the chloride salt, the sulfate salt, and the nitrate salt. 3 mistakes. Mistake mean it's not good. Well, this is not good. You cannot collect the gas like that because there's no gas that you're collecting. In fact, the water will not be filling up the measuring cylinder at all. This thing is not sealed up. That means you don't seal it. SEAL means you don't lock it up or something. And you want to collect the volume of gas. You don't want the liquid at all. So this should be a little bit higher, not immersed into the hydrochloric acid there. With this graph, I just want to highlight something you have learned in mathematics. Very, very important. This is a right angle triangle. Okay, right angle triangle. Is that correct? Yeah, that's correct. X1, Y1, X2, Y2, these are coordinates. To work out the gradient of this line, you will do Y2 minus Y1. That means the rise versus how far you go horizontally. Vertical, horizontal. Change in Y, because vertical is Y2 minus Y1, divided by change in X, X2 minus X1. This gives you the gradient. Gradient for this amount of product versus time, the change in the amount of product over change in time, that is your rate of reaction. So that means if we look at line number 2, 3, and 4, they give you the same volume of product. You get the same amount out, you get the same amount of product because you put in the same amount of reacting material. However much you put in that is the same, you're going to get the same amount of product coming out. Whereas here, you get double the volume of product because you must have put in double the amount of reacting particles. Last year, you learned reacting masses. Here, it means that you put in double the amount that reacted, you get double the amount of product. From these 2, 3, and 4, they give you 30 cm3 of gas. You get lesser, you get half. You get 15 cm3 of gas. You get half the volume of product because you put in half the amount of reacting particle. Simple as that. Now, looking at 2, 3, and 4, this student has done this thing under a particular condition for line number 3. So line number 3 is your standard. So when you go to line number 4, you can see the blue color line is less steep, less steep. Steep means how high is the hill that you want to climb. This is not very steep, and then you go to the next one. This is steeper because when you are down here, this is a more difficult hill to climb. So the gradient is steeper. When I have another line, this black color, gray color line is even steeper. So what I can say is the gradient increases. So the gradient become higher. So the gradient increases. But when you are horizontal lines, your gradient is 0. That's why it's very easy to walk on a flat horizontal ground. Here, your gradient is 0 because reaction stops. The rate becomes 0. No change in the volume of gas, no more product. Even though time continues, no more product, no more reactions, no more rate of reaction. Here, you can see that your reaction is like that at the beginning. And then I have this bit, the blue color one, the reaction slows down. You can hopefully see the gradient become less steep. Okay, it becomes less steep, S-T-E-E-P, less steep. Therefore, the reaction slows down because you have lesser and lesser and lesser particles that remain unreacted until all of them reacted. That's why reaction stops now. But we're comparing different reaction. Reaction number 4, reaction number 3, as well as reaction number 1. We draw this line at time equal to 0 because these are curved. We just want to compare at time equal to 0 there, the line. This line is less steep than the green, less steep than the pink, and less steep than the black color line there. So the gradient becomes steeper, the rate of reaction becomes faster. But 4 to 3 to 2, the reaction gets faster, but you still get the same volume of product. That's the key thing there. How fast versus how much. How fast is what you call rate of reaction. How fast. How much? How much is to do with amount. How much you get depends on how much you put in. The marks that you're going to get for your O-level depends on how much effort you put in. But how fast you can get there depends on, well, depends on you really. Now, from experiment 3, everything kept the same. When you decrease temperature, it will just get slower. So even though these are the answer provided for you in my work solution, but the idea really is temperature decreases, so rate will decrease. So you don't write using that symbol down. I can do that, but I just said temperature decreases, rate will decrease, but it's the same amount of product. Same amount means same volume of product because you are not changing whatever amount you put in. Therefore, you still must have the same volume of product. It's just getting slower. From 3 to 4, the gradient becomes less steep. It's getting slower. The next thing is double concentration. You double the amount, meaning times 2. You double the amount that put in. Therefore, you get double the amount of product. But concentration of solution also increases. Rate also increases. There were 4 factors that will affect the rate of reaction. Concentration of solution increases. Rate will increase if, number 1, concentration of solution increase, if temperature increases, if surface area increases for the solid, and if we use a catalyst, rate of reaction will increase. These are the 4 factors that you learned at the beginning of this topic, and these are the only 4 factors you need to know for the whole topic there. So that is why you get double the reacting amount. You get this black line going for number 3, double the volume because double the amount you put in, that is double amount. You also become faster. You can see the gradient of the black line is steeper than the pink line because the reaction becomes faster because concentration of the acid increases. Concentration double, the rate will also increase by that much as well. Now the next experiment is surface area because this is using fine powder. So surface area increase. So that means you become a faster rate of reaction, faster rate, but the amount of product is still the same. They don't ask for the volume, they ask what happens to the volume. Therefore, no change in the volume of gas. This is dissolved salt. In year 9, you learn if something is soluble, dissolve means soluble, you cannot filter. Filter is tapis in Malay. So you cannot tapis, you cannot filter something which is soluble, so filtration is not going to work. You need crystallization. Describe means you cannot just write one word. If you write one word, you get 0 mark. Describe, you got to talk about the process. For 1 mark, you don't really have to draw the diagram, but if you draw the diagram, you don't really have to, describe so much because crystallization, heat until saturated. You don't heat until it's dry, you heat until it's saturated. When you leave it to cool, the crystal will come out. Crystal is solid, solution is solution, so you can filter now the solid. Last thing is basically the test for gas. There are altogether 3 different gases: oxygen, hydrogen, carbon dioxide. Hydrogen, you get it from metal and acid, will give you hydrogen gas. Carbon dioxide, you must have carbonate. It's called metal carbonate. So metal cation, carbonate anions, and acid will give you carbon dioxide. This thing, you use lime water. Lime water will turn milky or cloudy. Hydrogen, you use burning splint. So the thing that still has fire on it, and it will produce a pop sound. Oxygen gas, you use something that doesn't have the flame on it anymore. So no more fire, no more flame, just the flicker, but it will relight. The key thing really there is, it will relight, it will become become burning again, it relights. And then this one, the burning spleen burns with a pop sound. So these are the three gases, and I can guarantee you at least one will definitely come up for your O-level. We just don't know which one, okay? This one, the lime water will turn milky or cloudy. So that means you get a white solid because you started out from a solution. This is a solution, just like your water, but it's mixed with calcium hydroxide. See-through, cannot see through, become a white solid there, okay? So hopefully that makes sense. There's work 1. And then there is work 2. Just very quickly. So work 2, counting the number of atoms in hydrogen peroxide, which is given, 2 hydrogen atoms, 2 oxygen atoms. Drawing the dot and cross is year 9. Write the chemical symbol of the elements, must include. Don't include that, you lose 1 mark. Show the outer electrons. If you show the inner electrons, you don't get the marks. Show the outer electrons. It's called reading questions. And at this stage, you must be able to read question. Catalyst simply makes the reaction go faster. It speeds up the reaction. Itself is unchanged at the end of reaction, as stated in your notes, in your syllabus. This is a family of metals. A lot of you put down group 7. It's not technically the name for the family of metals. It's for the whole of the middle of the periodic table. The one in between group 2 and group 3, you have the middle of the periodic table. They call it transition metal. Between non-metal and non-metal, they share electron, sharing of electrons, year 9. Make sure you can spell C or V for the covalent bond. This is one technique for collecting gas. You saw me setting this up in the lab. I think some of you had a chance to do this as well. So everything must be sealed to not allow the gas to escape. So the gas is collected there. And as you collect the gas will occupy this volume. The water level will come down. You start from that 0, and whatever reading is on the measuring cylinder, it will enable you to read the volume of gas produced. All of these collect same volume of gas. To reach this target, the shorter the time, the faster is the reaction. So this is the fastest reaction because it takes the shortest time. There are many factors that affect rate of reaction. I just talked about the 4 factors just now: temperature, surface area of solid, concentration of solution, as well as the use of catalysts. So here, if I just talk about temperature, I can just say kinetic energy. They move faster at higher temperature, collide more frequently, faster rate. This is an important explanation for 3 marks. Temperature, changing temperature will change the time taken to collect this much gas because it will change the rate of reaction. Why? For the 2 marks, we're going to talk about increasing kinetic energy when we increase temperature, collide more frequently. These are some of the key words. Yeah? You have more kinetic energy when temperature increase, collide more frequently, faster rate. Key terms, just like that, you get 2 marks for that and 1 mark for the temperature. This is a carbonate plus acid, you get carbon dioxide, and there's the gas you're collecting, gas syringe. There is a reason why I don't show the collection of the water, because you must have drank Coca-Cola or Pepsi or carbonated drink, because carbonated drink means carbon dioxide dissolved in water. So collecting carbon dioxide is best to use a gas syringe instead of using the collection of water, because carbon dioxide is soluble in water, carbonated drink there. We do averaging over 2 results here. I think I talked to you about the use of calculator. Be very careful about pressing a calculator like that. And your average cannot be higher than the highest number, cannot be lower than the lowest number. Average of this number must come in between. That is because you must have forgotten about the use of bracket. Same thing in physics, same thing in mathematics. Be very careful. Use bracket when you key in your calculator. We could see this concentration have a unit in the table. The higher the concentration, according to this, the higher the concentration, the time taken, not time, volume of gas. The time is fixed. Here is a fixed time. The volume of gas produced increases. In this much time, you get a lot of volume of gas. You get a lot of gas in this time. So that means this must be the fastest reaction. That is because concentration of solution increases, rate of reaction increases, you get more gas produced in the same time. 2.5 mole per dm cube is the one that will give you the fastest rate of reaction. Not to do with time, but to do with the volume of gas here, because this is volume of gas, the most amount of product in a fixed time. Just now, the previous question was fixed volume, but the time was changing. Here is fixed time, but the volume is changing. 2 different kind of thing there. Stopwatch is definitely essential. Essential means necessary, required to work out rate of reaction. This was your year 9. Measuring cylinder measures solution. People write down gas syringe. That is wrong because gas syringe is for gas. Solution, not gas. Therefore, you use all of these things as stated in the year 9 topic, the very, very last lesson you did in year 9 under reacting masses. They're also in your notes as well, yeah? Kept constant, we change one thing at one time. We change one factor at one time. The table that you had changes concentration of solutions. So all the other factors that could affect rate of reaction, you keep them constant. You don't change them. This is to ensure something you have learned in primary school, fair test. Okay, fair test. That means you change one thing at one time. Other factor, keep them constant. Constant means do not change it. Do not change it. Why? So that we have a fair test. So that we only change one thing at one time. This question was about changing concentration. This is a different thing. Some people write down to get a fair test here, which is wrong. This is why do we repeat? We repeat just now, reading number 1, and then we have reading number 2. In an experimental science, we can then average the results. When you saw the two results, they are pretty similar to each other. So this is about reliability. If someone else do it, if I ask you to collect an experimental result in this reading, and then I ask someone from 10C or 10A to do it, they should get similar result like you because your result is pretty reliable because you've done it 2 times. So the more you do it and then you average it, your result become more reliable. This is not fair test. Fair test is change one thing at one time, keep other constant. Reliable mean your result can be trusted. Can be trusted mean you repeat them and then you average them. The last thing was about test for carbon dioxide. I talked about the use of lime water. You get a cloudy or milky precipitate because that precipitate or that solid, if you don't like the word precipitate, you can just say solid, white or cloudy or milky solid is your calcium carbonate. Last but not least, I'll go through this work 3. So work 3 was the last work you did. It's a bit long, but the same idea, collection of gas, work out from this thing, subtract 10 seconds from each. You have 2 hands. You have 2 hands, your left and your right. Now, you have this apparatus. The moment you put in the magnesium, you have to close the rubber band. So one hand with the magnesium, one hand on the rubber band. You don't have another hand to do the stopwatch. That is the very reason why you put in the acid and then you start the stopwatch. We don't use really the word stop clock, we use stopwatch. We start the stopwatch, we put it on the table. Then when you start reading on the time, when it reaches 10 seconds, I put in my magnesium ribbon and I close it with my other hand. But I don't touch the stopwatch. I just add this at 10 seconds. That is because I don't have a lot of, I'm going to go straight to this. I cannot do all 3 things at one time. I only have 2 hands, right? So one hand for adding the acid, one hand for putting in the rubber band. So I cannot start timing again. Instead, I started timing from the very beginning. I added the metal at 10 seconds. So that means shouldn't be adding the acid, should be adding the metal, I think. So if you read the question, let me just read the question again. Yeah, did I add the acid or did I add the? Oh yeah, she added the acid. Sorry, so that must be add the acid, not add the metal. She added the acid, so that was correct. Add the acid just now. Okay, so she added the acid and then replaced the bunk. That means you don't have another hand to start the timer, which is why this student has to take 10 seconds from the final result. Take 10 seconds off, record it, you get 2 marks. Make sure you know how to read question. Do this. This 10 here refers to 10 cm3 of gas divided by the time, you get 1 mark. You collect 10 cm3 of gas in the measuring cylinder. So how much volume of gas divided by the time taken? Shorter time to collect fixed volume of gas, faster rate of reaction. Longer time, slower rate of reaction. So what can we say? How does the rate changes when the length of magnesium ribbon changes? These 2 are the worst done questions because some of you do geography, some of you don't do geography. But just like in geography or biology, you have to talk about what happened as this changes. As the length of magnesium ribbon increases, what happened to the rate? Have a look at the table. As the length of magnesium increases, the rate increases in value. That's it. You get 1 mark, stating the obvious. They also say, the next part, As the length of magnesium increase, the surface area increase. So when the surface area increase, the rate also increases. That was your surface area. Exposed area to the reacting particles increases, your rate also increases. This is how. Therefore, you have to state what changes and therefore the other stuff. This next thing was also very badly done. A lot of you just say increase, decrease. Do you really expect to get all the marks for 3 marks just like that? You say, is it correct or incorrect? You must show which results. So the people who don't say which results, this is plural. That means you don't read the question, you don't know how to read the question, or even worse, you don't know how to read. That is a big problem for a year 10 student, don't know how to read. Which results? Therefore, you need to read. The rate doubles, meaning multiply by 2, when the length of magnesium is double. There are 2 answers to this. If you go from 1 to 2, you double the length. The rate also doubles. 0.267 times 2 is roughly this much value. So it is correct. I show when this double becomes 2 cm, the rate doubles. 0.267 multiplied by 2, I show the value. Okay, it's close to that. If I decided to use the pink color one, 2 cm become 4 cm, double the length. 0.5 times 2 is 1.0. This is 1.54. So if I do the pink color comparison, 2 and 4 cm, it doesn't double. So that means it's incorrect if I follow the pink color. If I follow the black color, it is correct. So there are more than one answer for this question. Use the table. This is an experimental question. So it's mostly down to the experimental result. It's not theory. It's not explained why. It's explained using the result. I already talked about that. This is the test for hydrogen. I already talked about it in work 1 just now. How can you test the gas? Show that. That means confirm the result. You cannot just say use burning or light the flame. You need to confirm it with the result. The next thing is a metal carbonate, because marble chip is metal carbonate. Added with acid, you get carbon dioxide. This question is about counting the number of bubbles. Instead of using measuring cylinder or gas syringe, you just count the number of bubbles. In the fixed time, the more bubbles you produce, the faster is the rate of reaction. So this is very fast because the temperature increases, the rate of reaction increases, as you know. And that was what they asked you in the next question. What happened in terms of the particles when the temperature increases? For 2 marks, it's the exact same question from work 1. The exact same question from work 1. Talk about more kinetic energy, then move faster, collide more frequently, rate increases. Rate increases. Of course, explaining, so you need to explain the whole thing. At very high temperature, you're going to get a lot of bubbles. It makes it difficult to count manually. Okay, it doesn't make sense for you to count how many bubbles when it's very rapid, when it's very fast, very difficult to count. Okay, now my graph is wrong. My graph is wrong because I had 5, 10, 20, 30, 40. 5 and then 10 should be 15, should be 20, should be 25. But the highest value is 37. So I was going to cross it out, but I forgot to do that. So I'm not sure whether you copied the wrong stuff or not previously. Make sure you have the same scale. If this is 0, if this is 10, the next one was 20, the next one was 30, 40, and 50. There is an equal spread between each of these 10 small squares. This is drawing graph. A lot of you managed to draw the graph correctly, unlike me. But a lot of you included, you start from 0. But this data is not provided in the question. Do not draw the data that are not provided by the question. They never say 0 degrees Celsius is 0 bubble. They never say that. It's not in the data. Therefore, you cannot assume. So draw your graph, label your axis, have the scale correct. Just like that, you will get your 3 marks. Okay, this is an experimental paper. So, you got to try and score as well as you could. These are the last questions I'll go through with you today and particularly mark the end of our lesson. This thing I use calcium hydroxide. By right, I should write lime water. Lime water is the test for carbon dioxide. So word equation is not formula. Word mean write using English word. Carbon dioxide plus lime water. I get this insoluble product. This is the milky, this is the cloudy, this is the white solid that you get. It's a solid. It does not dissolve in water. Does not dissolve mean insoluble in water. Why? Because carbon dioxide is present. It reacts with lime water. You get this insoluble product. Why does it cause it to turn milky? Because carbon dioxide is present. Because carbon dioxide is present. That's why you get this insoluble. product which does not dissolve in water. The white, the milky, the chalky solid, the result, the positive result when carbon dioxide is present. Okay, I just leave it there for today. I think if you got any questions, you can always text me to find out. For the people who are on quarantine and stuff, just try your best to catch up, and we'll start a new topic next week. All right.